So we are ready now for our next experiment with our stream table unit. And when I say experiment, we have not just an exploration, there's an independent and a dependent variable. And so for this experiment, we are working on what effect changing the rate of flow will have on the landscape. And this time we're not measuring the width or the depth of the stream channel or how far the sediment moves beyond the original cliff. This time we're actually measuring and observing particle size. Sediment size is another way to say it. And so we're going to be looking at what size sediments in general are left in the stream bed and what size make it to the alluvial fan. So speaking of alluvial fan, there are two background questions that go with this experiment. And so where it says another term for rate of flow, you should put there discharge. That's spelled D-I-S-C-H-A-R-G-E. So that we're changing the discharge rate today, which is like saying rate of flow. And then just to review, when we saw this in our exploration and also in our gradient experiment, but when a stream reaches a flat plane, that sediment, triangular shaped sediment pile is called an alluvial fan. Alluvium is another word for sediment in science. So alluvial fan is spelled like this, A-L-L-U-V-I-A-L, alluvial fan. So let me show you now the setup that I have here. So this looks like it did before. The thing that you can't see is that every round this time is going to be just set up on one block because that is not our independent variable today. And so I'm going to be using these cups here, these containers that have different size holes this time. And so I'm going to start with the small hole, then with the medium hole, and then with the large hole. And so I'm going to do the small hole off camera because you've seen how slow that it goes, the rate of flow, but I'll be back to show you those results and to help you with the round one results. And then the other two, I'll have you actually watch the flow.